Hi, I am Dr. R. Gururaj, Assistant Professor of Computer Science and Information Systems Department, BITS Pilani, Hyderabad campus. You are welcome to this series of video lectures on Database Management Systems course. And the purpose of this course is to impart knowledge on basics of database management systems and various approaches and techniques that make the design and construction and storage of the data and database more and more effective. And at the end of the course, we believe that the student should be able to model his database, design his database, construct his database, and write some applications using some programming language so as to access the data contained in the database and manipulate that. That is the purpose. And coming to the content of the course, first we talk about introduction and overview of the DBMS, where we cover various basic concepts related to database management systems and then various definitions related to this subject. Then we go to conceptual database design using ER modeling technique, and which is a very high level data modeling technique which gives appropriate and then sufficient initial idea about the database we are going to construct. Then we see how to translate the schema in ER in conceptual at conceptual level can be converted to logical level, which is according to the model or data model of the specific database management system. We have so many data models available, like network model, hierarchical model, object relational model, and so on and so forth. Out of this, the relational data model is very important and then very popular data model. And all the concepts related to database management systems under this course we will be learning in the context of relational data model. We see what are the basics of relational data model, and then we talk about the relational algebra and relational calculus, which are in fact the formal query languages for relational data model and which have a strong mathematical background. Then we talk about SQL, structured query language, and which is a very popular commercial query language for relational data model. In fact, any vendor, any DBMS vendor for relational databases like Oracle, Informix, Ingress, whatever it is, they support SQL standards, using which the users can pose queries to the database and retrieve the data back from the database. Then we talk about schema refinement. So whatever conceptual database design and then logical database design gives us very preliminary and then initial design about the relational database. Then we take up the refinement activity and we also discuss about the normal forms, and this makes the database more and more useful and then effective. We have various normal forms starting from first normal form to fifth normal form. We will see what are the various rules involved in those normal forms, all those things. Then we discuss about how data is stored on the physical storage, basically on the disk storage. Then we talk about the approaches or techniques related to fast retrieval of the records from the database, where we discuss about hashing techniques and then indexing techniques. Then transaction management and then concurrency control when multiple transactions are being executed concurrently on the database by various applications, that we will discuss. Then we also discuss how to recover from the crash so as to maintain the consistency of the database. And when we run applications, database applications, which in turn connect to the database and then retrieve the data and manipulate it, and due to some reason the system may crash due to various software failure, or it could be hardware failure or power off, whatever it is. So when such thing happens, and what are the various techniques, approaches so as to bring the database to the previous consistent state. And when a database is in consistent state, it reflects the real world scenario. So that's why always it is a requirement, basic requirement, that the database must be in some consistent state, and when you run your applications and when the applications run transactions, the database will be taken from one consistent state to next consistent state, and in between when the transactions are under execution, that may leave the database in some inconsistent state, and unfortunately something goes wrong, a system crash happens, then it may leave the database in some inconsistent state. So we should take appropriate measures so as to take the database back to the previous consistent state and then restart the transactions again. So that is normally happens. So this is the content of the data course, database management systems, and these are the books. And first two books by Raghu Ramakrishnan and others, and then second book is Elmasri and Shamkant Nawate. I heavily follow these two books, and many diagrams have been taken from the second book, and content has been taken from first and second book. Okay, and remaining books are also very good. That is the book by CJ Date and the other book by HF Korth. These are very good books, and then students can refer to these books for further details. Let us start with our first lecture session, which is about introduction to the database management systems. Here we cover what is a database, what is data, what is a database system, and then what is DBMS. What is a database system environment, and what is the difference between, or what are the advantages of storing data in DBMS rather than storing in traditional file systems given by, supported by any operating system. This is going to be the content of the first lecture session. And coming to the introduction, databases and systems to manage them have become significant components of any present day business of any nature, and it is hard, in fact it is very hard to find any organization or the business which is not maintaining or not having its own database. Why these organizations and businesses, they use their or create their own databases and then maintain their own databases? The purpose is these databases help businesses to perform their day-to-day activity in an effective and then efficient manner. And for example, you can take banking business, travel ticket reservation business, library management, and the list is unlimited. All these applications, all these systems, automated systems, they use some database in one form or the other. Here if you look at the database applications, they have some program which accesses the database and retrieve the data, process or manipulate the data, and then put it back into the database. So this basically happens with any database application. Advances in technology have given rise to new concepts like multimedia databases, GIS databases, and web data, data warehousing, and mining applications which are closely related to databases. And these applications, what I have mentioned now, they have different requirement than the normal applications. They need to handle complex data, they need to handle data in multiple formats like audio, video, and so on and so forth. So that's why the advancements in the technology has given rise to these advanced database applications or systems. Then let us see what is data. In simple terms, I can define it as follows. A data is a known fact that can be recorded and that has some implicit meaning. And for example, name can be associated to a person or a building or a course or a dog or something like that. Telephone number, city, etc. These are the facts and that can be recorded and which has some implicit meaning. And basically these data or facts, they can be attached, they must be attached to some real world entity like person, student, vehicle, or institution, so on and so forth. This data can be stored in a file on a computer. And before these database management systems came into existence, or before the invention of the computers, and people had databases, they used to maintain their databases in ledgers, books, account books, so on and so forth. And that is the data. It is a fact that can be recorded. Then what is a database? It is a collection of related data. It is a collection of logically related data, and a database is designed, built and populated with data for a specific purpose. And if you take company database, it contains data about the company, about the employees of the company, about the projects of the company, about the marketing of the company, so on and so forth. So like that it should be related. The collection of logically related data is called as a database. Then what is a database management system? Database management system in computer terminology, if any system is collection of programs written in some programming language. Similarly, database management system is a collection of programs that enables users to create and maintain databases in a convenient and then effective manner. Basically it is a collection of programs, otherwise I can look at it as a software. DBMS is a software system that facilitates the following. So what are the functionalities or the facilities provided by this database management system to the end user? We can define the database, that is the first purpose, functionality. Next we can construct the database, then we can manipulate the database for various applications. What do we mean by defining the database? This includes defining the structure for the databases and basically how data need to be stored in the database, and then what are the data items that need to be stored, and what are the data types of the items that are being stored, what are the various constraints that need to be enforced on the data items, and what are the indexes, all these things. When we define this, and that is how we have defined the database, and all these descriptions about the database or definitions about the data items or the database structures are stored in database catalog or data dictionary, and we also call it as metadata. It is data about the data. The second purpose is constructing the databases. First we have defined the structure of the database. It is only a structure. It is like, for example, in relational data model it is just creating the structure of the table. If you just define the structure of the table, in fact it is not going to contain any actual data. Next we need to populate the database with the required data, that is called as constructing the database. This means storing the data into the database structures and storing on some storage medium, that is called as constructing the database. You construct a table, and in the first phase, that is while defining you construct the table, and then while constructing the database you keep on pumping data into the tables, that is called as constructing the database. Just mere storing data in database does not serve any purpose, and we need to have applications which retrieve the data and then manipulate the data from the database. That comes as the third functionality of the database management system. Manipulation of data contained in the database for various applications. This encompasses activities like querying the data, that is retrieving the data back from the database, taking it into the application programs, or inserting new records into the database, or updating some of the data items and deleting certain items from the database. All these things come under manipulation of the database. So now we have seen what is data. Data is a fact that can be recorded, and database is collection of logically related data, and then DBMS or database management system is nothing but a collection of software programs which work collectively to provide some end functionality to the user. Okay, so that is database management system. It can be seen as a software. Then what is a database system? If you look at the environment of the database system, it comprises of the actual storage, like what we see here. This is the actual storage, and then whatever is available in this grey colored box, that is database management system software, which contains programs to manipulate or manage data, and then it also comprises of application programs written by programmers, and which will use database management system, interact with the database management interface with the database management system, so as to retrieve data and then manipulate or process the data. All these three components put together, it is called as database system. And of course end users who are external to the database system, and they interact with the database using through these interfaces provided by application programs. So a database system consists of application program, first thing. Second, it consists of database management system software, and third, the storage, the actual storage where we actually store our data. This is about the environment of the database systems. Then if we take the example of any business, for instance saving bank enterprise, okay, banking industry, and information about the customers and savings bank accounts need to be stored. How we can store this? Without using database management system also we can store this information. How it is possible? We can use the file systems provided by operating systems and then we can store this data there. But it is not an elegant way of doing or storing or managing data, because the drawbacks with this approach are as follows. The disadvantages. First is difficulty in accessing data. When you want to retrieve the data, suppose you assume that you have written a C program and you have stored the information related to customers and then their savings bank information or account information in some as rows in some file provided by operating system. Then to retrieve the customers whose balance is more than 10,000, how you can get that? You need to write a special function or a program which will connect to the open the file in the disk on the disk, and then it will read line by line and then look for the required record and then fetch it into your program. So that is very cumbersome. It is not an elegant way of doing it. So today you may have 3 requirements and tomorrow the requirement to data retrieval requirements may change or it may increase in number. Then what you will do? Every time the programmer will have to write a program or a function to retrieve the required data depending on the requirement. So that is a very cumbersome process. That is why we face lot of difficulty in accessing the data. The second drawback is redundancy, and which leads to inconsistency. If you are not having a database management system and the same, what do you mean by redundancy? It is duplication. It is nothing but duplication. And if the same information about the customer is being placed at different files on the disk, then if there is a change in the data pertaining to a customer, then what we need to do? We need to figure out all the files that contain information about the customer and we need to update that. Suppose today the customer's phone number is some 9498 something like that. Tomorrow it may change, and then if you are redundantly storing the information about the customer in multiple files on the disk, then if there is a change in the phone number of a customer, then you need to figure out all the files, you need to find all the files, you need to go to the appropriate record and then modify that. And if you have stored by mistake, if you have stored the information phone number about the customer in 3 multiple files, then if there is a change you need to figure out all the 3 files and then you need to change that. And if you miss to do that updation in at least one file, that leads to inconsistency. Inconsistency means revealing something about an entity and then revealing different facts or giving different things at different places. At one place you have modified, the phone number is different, in the other file you did not update that, and then that gives a different information about the given entity, that is the customer. So that is inconsistency. At one place you say one thing, at other place about the same person you say something else. So that is inconsistency. That should not be there. This is coming because of what? This is all because of the redundancy. That is, since you have stored the same data item or the same fact about the person at multiple locations, you are leading to this kind of situation. Because if you use these file systems to store data, then it may lead to inconsistency. The next point is no recovery on crash. If there is a crash, and then if you have modified your database and if it is half done, then if there is a crash, then what happens to your files? You don't have proper arrangement or the techniques to recover from the crash. Then the next point is the security provided by every operating system with respect to its file system. It provides some security like login, password, something like that. So but whatever security that is provided by the operating system file management system, that is not sufficient. Then data integrity is not maintained. That means integrity means what? The inconsistency and integrity are 2 important concepts in database systems. Inconsistency talks about reveal same fact at multiple places about the same entity. Integrity is always maintain correct data in the database. Suppose if I am maintaining a customer's information and with respect to the age of the customer, and the domain says that it should be an integer. Okay, it is an integer, but can I enter 155 as age of a customer? that looks very absurd and then meaningless. And whenever I am writing a database or creating a database or writing an application, I should make sure that integrity is maintained. What do you mean by integrity? The semantics should be correct for the data item you are going to capture into your database. That means whenever I write my application, I can make sure that I can write some small piece of code or code that can check whether the age of a person or a customer is in between the 20 and 60 or 70, whatever is the limit, whatever is the requirement of the application. That I can do, and I can maintain that kind of integrity at the same time. And you can maintain integrity in many forms, that is foreign key, primary key, unique key, domain, type, all these things. When you are using operating system provided file systems to store the data, these integrity constraints cannot be enforced. And if you want to do something, the programmer will have to do it on his own, and he has to write the program or some code from the scratch. That is very, very cumbersome. And owing to these disadvantages or the drawbacks, and people have turned towards the database management systems. And if you look at the brief history of the database management systems, the actual usage of database management systems have started in early 1960s, and after 1970s the popular data model, that is relational data model, has been introduced. And nowadays many organizations or the enterprises, they use databases in many different scales to maintain their data for day-to-day business activity. And coming to the advantages of the DBMS, the disadvantages have prompted people to look towards the database management systems. What is the advantage? The first biggest advantage is data independence. What do we mean by that? The application programs can be insulated or isolated from the internal storage details, conceptual storage or the physical storage details. That isolation is possible. At the same time, the conceptual database design of a database need not be dependent on the physical storage. This is called as the data independence. We will look into the details of this data independence in the next class. Okay, let us not worry about that. And the next advantage of using database management system is efficient data access. You take any commercial database management system, it comes with some query language. For example, if you take Oracle, which is a relational data, which is based on relational data model, it comes with the SQL, which is a query language for that relational model, or Oracle, Ingress. You take any relational model database management systems, they support this SQL standards. Using these query languages, the programs or the end users can pose their questions or queries for data retrieval or manipulation of the data, which is not there in the traditional file systems. Then coming to the next advantage, that is data integrity and security can be maintained. You can enforce integrity constraints in the form of unique key, primary key, foreign key, domain constraints, type, everything. And this makes the data you are storing it in your database more and more correct and appropriate. And at the same time, the security and access controls can be permitted on different applications and users by the database administrators at different levels of granularity. That is possible, which is not there in file systems. Then comes data administration. Once you construct the data, you can administer, you can perform the administration activities to improve the quality of the database. You can construct indexes to meet the performance requirements of the applications, or you can fine tune the database, you can create table spaces, you can create clusters, so on and so forth. So all these come under database administration, and then which we will discuss in the later parts of the course. And then this helps making your database system more and more effective and then efficient. Then concurrent access and then crash recovery management is possible in database management systems. That is, multiple applications can concurrently, simultaneously access the data contained in the database. And when multiple applications they run simultaneously, that may lead to some problems related to consistency. And you have some modules which are integral part of the database management systems, that is concurrency control module, which takes care of avoiding the problems which are related to concurrent access to the database. That facility is available with the database management system. And then crash recovery. And we have a integral part, that is a recovery module which is part of the database any database management system, which takes care of the recovery from a system crash due to hardware or software failures, which is not there in file systems. Then finally, reduced application development time. The requirement, if you look at the requirements of different database programs or applications, the requirements are very common. Keeping that in mind, all commercial database management systems, they come with functionalities that need to be provided by the application programs. So this reduces the application development time. Now the programmer can solely concentrate or focus on the actual logic rather than focusing on other issues which are need to be provided by the application, and which in fact have been taken care by the database management systems with which he is going to interact or interface to connect to the database. So these are the various important advantages of using a database management system over using traditional file systems, and these advantages have given rise to usage of database management systems in the day-to-day life by various organizations and businesses. At the same time, all these advantages are not coming free of cost. There should be a trade-off. So what are the disadvantages? You need to pay extra money. Of course, some database management systems are free of cost, but many of them are, you need to buy them, you need to purchase the licenses. That is extra cost involved in software, purchasing the software, and you need to have additional hardware to support the database management system programs or the software, and you need to train the personnel of the enterprise or the business to get acquainted with the usage of the database management systems. At the same time, these commercial or database management systems may not be suitable or effective for certain applications. For example, if you look at the real-time systems, they have strict deadlines or real-time constraints, and due to overhead of the supporting because of supporting this crash recovery, concurrency control and all those things, the software has become very bulky, and due to this overhead they may not be able to support real-time applications where they have strict real-time constraints. And at the same time, and when you have a requirement such that the functionality or the data retrieval or processing requirements are very minimal and then well defined, and you have very limited number of operations, then you don't have to look for database management systems, because they come bundled with many other facilities which makes it very bulky and then slower. So in such cases, you can write your own program, or you can write specific functions and programs to access data in your own database and then get away with that. And at the same time, in some cases, the data manipulation or data processing requirements of some applications may not be supported by the query languages. In such cases also, these traditional database management systems may not be useful. Apart from this, all the advantages whatever we have seen in the previous slide, they are very much valid, and then many organizations or businesses, enterprises, they use commercial database management systems to handle or manage their data in an effective and then efficient manner. Then coming to the summary of this session, we have seen what is data. Data is a fact that can be recorded and which has some implicit meaning. What is a database? Database is nothing but collection of logically related data. What is a database management system? It is a collection of programs, or it can be seen as a software using which we can do three things. First thing is we can define the database, we can construct the database, we can manipulate the data contained in the database. And what is the importance of the database management systems? So they help you in running your business in more effective and then efficient way, so as to improve the profits of the organization or the enterprise. And storing data in traditional file systems, okay, it has lot of drawbacks which we have discussed. It has no consistency, integrity constraints cannot be enforced, and redundancy is there, and crash recovery and transaction concurrency management is not there. Owing to all these drawbacks, and people have prompted to go towards the database management systems. And coming to the advantages of the database management system: data independence, concurrency control, database recovery, and excellent beautiful data retrieval mechanisms using query languages, and it provides fast and quick application development due to the facilities and functionalities supported by the database management system. Okay, we end our first session here, and we will start with the next session where we discuss the other important concepts related to database architecture and data models. Thank you very much.